Hello, everyone. My name is Pavel Despot, and I am part of the cloud team at Akamai. Today, we're going to focus on how we manage the user experience during peak events. We've all been on the other end of peak and busy, right? The experience isn't good. You get errors. You hit reload, and hitting reload just puts more strain on the server and makes the problem worse on the back end. Now, if you look at high demand days and think of in the Americas, Black Friday, Singles Day, product drops, ticket sales, we have seen traffic spike over 25 times, sometimes in a few seconds. So if you're responsible for that uptime, you know how this kind of load is going to tank performance or just outright crash the site. So what can we do? Well, this notion of managing users at the edge is where this comes in. To talk about that, I am joined by Martin Jensen, head of engineering at Hewitt.
Great to be here.
Help us understand what exactly is a virtual waiting room, and what does that mean to me from an infrastructure and user experience standpoint?
A virtual waiting room sits in front of your site or key bottlenecks and controls the rate at which users are let in, ensuring you never exceed capacity. So it's a shift in thinking from how can I scale up and run my systems faster to how can I control the flow into the user journey and give visitors a reliable experience. Hewitt uses a simple HTTP 302 redirect to manage traffic flow. Here's what that looks like when you've integrated Hewitt on the edge. When a visitor makes a request, the Hewitt connector performs two quick checks. Is the request targeting a path protected by Hewitt? And if so, does the visitor already have a valid queue token? If the request is protected and the visitor doesn't have a valid token, they're sent to Hewitt using a 302 redirect. At this point, Hewitt evaluates the traffic conditions. If traffic is below your configured threshold, the visitor is immediately redirected back to the original page without ever seeing the queue. But if traffic is above the threshold, Hewitt places the visitor in a waiting room hosted on our infrastructure. There, the visitor gets a branded experience with real-time queue info like place in line and estimated wait time. And once it's their turn, they're redirected back to your site with another HTTP 302 and receive a signed token. That token lets them continue their user journey without being sent through the queue again.
Can we talk a little bit about the queuing situations? Explain a little bit more about how that works.
Hewitt works using an actions and triggers framework. You can cover your whole site or app, specific landing pages, or dynamic requests like, for example, add to cart or login. And the triggers include request URL, request body, user agent, cookie, HTTP header, and also JavaScript. And the power here is the granular traffic control. From the Hewitt dashboard, you get accurate real-time data about all incoming traffic. You can then check your CPU, memory usage, or other metrics in your monitoring tools, and then tweak the traffic flow up or down in real time based on how your systems are performing. You can send real-time messages to all visitors in the waiting room, giving inventory and status updates. And if something unexpectedly goes wrong, you can simply pause the queue, holding visitors in place and communicating with them while you resolve any issues. All of this can be done either through a web-based platform or via REST APIs.
So can you show us a little bit about how that integration works? How do we get some of this data? What can we see as IT folks when we're managing this massive event on, Soccer Monday?
So at Hewitt, we offer more than 20 connectors for the edge, server-side, client-side, and mobile apps. And today we'll focus on the Akamai Edge Worker integration. This approach lets you use the power of Akamai Compute to run code at the edge, meaning you don't need to touch your origin, and you get the performance and reliability benefits of edge computing. So at a high level, what we'll be doing is configuring the Hewitt logic in Hewitt, creating the Edge Worker in Akamai, inserting the Hewitt connector code, and then seeing the user experience. So I'll start in Hewitt and define what I would like to protect. I talked about the actions and triggers framework before. Here's where I'll create my rule for what the virtual waiting room protects. And to do that, I create an integration rule. Again, there are several options, but for this demo, I'll make it based on page URL. So the trigger is my hostname, and I'll set the action to queue. Now we'll move into Akamai. So we have our properties set up in Akamai, and I have created an edge worker. In that edge worker, we'll create a version where we'll drop the Qt code. And finally, we'll activate the edge worker version. In the property, we're going to create some variables, including the Qt API key, and we'll create 3 rules. One to ignore the calls to the integrations config file, a second one to retry the call if there's a failure, and a third to get the cached integration configuration from Qt. And finally, we'll activate the property in both our staging and production environments. Now let's test the integration. I hit the protected page, and right now I'm not being sent to the waiting room. So let's inspect the headers. I can see execute connector equals Akamai, so I know the integration is firing, but there is no queue yet. And that's because you can control the visibility of the waiting room on top of the Akamai Edge Worker connector. So let's go back to the Qt platform, activate the integration rule, and publish the changes. Now the Edge Worker is pulling the correct integration configuration, and if I revisit the page, the waiting room will kick in. You can now see that I'm redirected to a customizable waiting room with clear messaging and expected wait info. I can see I've been redirected with that HTTP 302 redirect and will be sent to the protected page when it's my turn. And that's it. So we've integrated a virtual waiting room with full traffic control running at the edge. I've got examples from 2 Akamai Qt customers that we can look at. The first one, we have a major European retailer using the virtual waiting room for 24/7 protection during the holiday season and to save on scaling costs. So the yellow line in this chart is the outflow cap. It's the number of users per minute allowed to hit the protected pages. And the green line is a total visitor inflow into that protected area of the site. For the first half of November, they can handle up to 1,000 visitors per minute. That's enough most of the time, but during 7 sudden spikes, we can see that traffic exceeds that cap. There, the queue kicks in automatically. It absorbs the spikes, keeps visitors waiting a few minutes, and then ensures that the site remains stable. Then, later in November, they scale up to handle up to 2,000 visitors per minute and adjust the waiting room outflow accordingly. For this period, if incoming traffic had exceeded 2,000 per minute, then the waiting room would have functioned exactly the same way. So what is the overall result here? They focused their scaling investment around the major holiday and ensured that short spikes didn't compromise the user experience. Then we can look at a top 10 global sneaker retailer. They're dropping a limited edition shoe with restricted inventory and expect huge demand. They set up a scheduled waiting room which collects all visitors arriving before the sale on a countdown page hosted on Qt's infrastructure. Then when the sale starts, the 100,000 visitors that showed up on time all get randomized to ensure no one gets an unfair advantage, and they're then placed in the queue. Everyone arriving after the start time get added to the end of the queue on a first in, first out basis. As inventory nears sellout, about 18 minutes in, they reduce outflow to avoid overselling. And once sold out at 20 minutes, the rest of the queue is redirected to a page that confirms sellout and promotes stock alerts, newsletter signups, and associated products. And the overall result here? They stayed online, gave customers a fair shot, and avoided scaling for traffic that would be 20 times larger than their inventory. So, to recap, a virtual waiting room gives you control over peak traffic to support your critical infrastructure when it's needed the most and gives you peace of mind on those peak days. We have found that teams who use virtual waiting rooms, they report less stress on their busiest days, such as Black Friday. They gain focus on other core issues by knowing peak traffic is under control. They deliver an improved online experience to their customers, and they improve collaboration with and also get some cover from the business.
Thank you so much. And I think those last 2 points are just worth reemphasizing, right? This is both a technology and a business solution. Please look for more videos from us around these types of solutions. Thank you very much for joining us.